This question tests your understanding of the relationship between ionic radius and nuclear charge in isoelectronic systems. Start by reading the question. We're asked to find three ions that are isoelectronic with, or have the same number of electrons as, neon. Arrange the ions from largest to smallest, and then explain how the correct order was determined. Our plan for this problem should start with pulling out the periodic table and locating neon. We'll have to add or subtract electrons from nearby atoms to make ions that are isoelectronic with neon. Once we have our ions, we'll need to recall any trends we know for ionic radius so that we can arrange the ions from largest to smallest and explain our reasoning. Now we can solve the problem. Look at the atoms on either side of neon. We have fluorine, which has one less electron than neon, and sodium, which has one more. To make them isoelectronic with neon, we'll have to add one electron to fluorine, giving it a charge of -1, and we'll have to remove one electron from sodium, which will make it +1. To get the last ion, we'll need to go to either oxygen or magnesium. It doesn't matter which one. Let's do oxygen. It's 2 electrons short of neon, so we need to add 2 electrons and give it a charge of -2. Okay, we have our 3 ions, now we just have to arrange them from largest to smallest. Let's write down our reasoning as we go. There's less of a chance we'll make a mistake, and it'll also double as our explanation. All of the ions have the same number of electrons, so the only major difference between them is their atomic numbers. As the atomic number increases, the number of protons in the ion increases, and that means that the nuclear charge goes up. If the nuclear charge goes up, the nucleus can pull harder on the electrons and decrease the radius. So for isoelectronic systems, the size of the ions will decrease as the atomic number increases. Oxygen has the smallest atomic number, so the oxygen ion will be the largest. The fluorine ion will be next, followed by the sodium ion. Finally, check your answer. Make sure the ions are written from largest to smallest, and not the other way around. And check that the explanation is clear and concise.